Hey guys, it's Mr. Engel here. This is your intro video for Unit 13. Unit 13 is the last of our physics units. It's basically an extension on Unit 12, which was about refraction of light. So if you had a pretty good idea about how this all worked and you understood that very well, and how the stuff in the mirrors unit worked, then you're going to be just fine for Unit 13. It's just basically the last extension of that knowledge. When you open the guide, we're going to go through the lessons as we normally do. We'll get back into these videos. This is a short video that kind of takes you back to a little bit to refraction, similar to what we did in the concave mirrors. Or not refraction, but basically it takes the reflection from the concave mirror and applies it to refraction through a lens. Then this is Bill Nye, does a really good job of showing you how that works a little bit, and then once we've got our heads around it, this is a little bit more complex video that gives a very good digital image of what we learn here in the units, and we will go through all this stuff together. If you're doing this on your own, make sure that you're paying very close attention about how to do this. One is an image that is behind the focal point of the lens. And then the other one is how to do an image which is in front of the focal point before the image. Is in front of the focal point in front of the lens. And if you understand how to do both of those, then you can go and do this last assignment, which gives you multiple different examples. So if you can take those rules from both of these different ways of drawing how the rays are refracted through a lens, then you will know how to do that assignment at the back. Everything else is basically just kind of fill in the blanks from learning that you had up here, but you are going to need to know how to do these two to apply that knowledge on this last assignment. We're going to do this together. I'm going to take you through this whole thing. When you're doing location, you're speaking to what is the distance of the image that's being portrayed through the lens compared to the object. So this is the actual object, okay? This is the image on this side, or even when you're doing this, whatever the image is, what is it in relation to the lens as compared to the object? The orientation is, what does the image, is it upside down or is it right side up compared to the object? So the answer would be inverted if it was upside down, and it would be upright if it was right side up. Size is it larger or smaller than the object? So if the object is bigger than the actual image is, then you would say smaller than the object. If it's bigger than what the object was, you'd say larger than the object. And then the type would be, is it a real image? Is it a virtual image? Real, basically, if it's on this side of the lens, it's a real image. If you have to do the work back over here to get an inverted image, or sorry, if you have to use the backside of the what would you call it, the rays, if you have to use the backside of the rays to project an image back on this side of the lens, then it's going to be a virtual image, okay? So if your image ends up over here when you do your drawing, that would be a real image. If your image ends up over here after doing your drawing, then that would be a virtual image, okay? So type will be real or virtual. Size will be larger or smaller than object. Orientation will be upright or inverted. Inverted means upside down. And then location will be closer to the lens than object or further away from the lens than the object. Okay? We're going to cover all this in class. Make sure you're there.